Hi everyone, welcome to this Getting Started with Custom Development in nRF Connect SDK. My name is Øyvind Sandberg. I'm a Senior Application Engineer in the Technical Support Team here at Nordic Semiconductor. So before we continue, let's go through some practicalities. The duration of the session will be about 60 minutes. This includes the Q&A session. We do encourage that you send in your questions via the questions sidebar. All questions are anonymous, but please keep them to the topic of today. The chat is not anonymous, so we do not encourage asking questions there. If you have any questions further after the session today, you can go to DevZone to find answers, or you can ask questions there. A recording of this session will be available on our website after the session. So the agenda for today will be more hands-on. We'll start with the basics, install nRF Connect SDK and Toolchain Manager, then open and program a project using the built-in IDE or the command line tool. Then we'll add a custom board. After that, we'll add a basic modem communication. And then in the end, we'll add a sensor. I'll be using the nRF 9160 development kit. But you can also use the Thingy 91. Just make sure to go to our info center and then under prototyping platforms, go to Nordic Thingy 91 and then firmware. It is especially important to read through this documentation if you're using the Thingy 91. If you're new to the nRF Connect SDK, you can find the documentation on our info center. Just go to the link shown here. Then, from the front page of the info center, you can go either via the banner, click on the nRF Connect SDK documentation, or go through Software Development Kit on the left-hand side, and then nRF Connect SDK. Here you'll see several releases that we have, the latest or the master branch, and then the official releases or tags shown below. The latest development can be found on the master branch. Be aware that this may tend to be unstable when we're testing new features and so on. So we do recommend using the latest NCS tag. However, when using another mobile network provider, there are several modem firmware versions that have not been certified. To figure out if your network has been certified, you can go to nRF 91 series. Then under nRF 9160, go to the compatibility matrix, and then mobile network operator certifications. Here you'll see a table with the different operators and then what modem firmware they are certified with. And then also what version of the NCS you can use with that modem version. So for example, Verizon, they are now certified for modem version 112, and that is then certified with the NCS version 121. Let's get back to the NCS documentation. For now, I'll be using version 140. Here you'll find all the information you need about nRF Connect SDK. I recommend reading through the release notes, getting started, user guides, and also have a look at the applications and samples that we have. For now, let's go to getting started and then installing the nRF Connect SDK through nRF Connect for desktop. So go ahead and download the nRF Connect for desktop and then install the Toolchain Manager. The Toolchain Manager is available for Windows as an official release, and it's available as an experimental release for Mac OS. So for Linux and Mac, we recommend using the Getting Started Assistant or install the nRF Connect SDK manually. Alright, so when you install the nRF Connect for desktop, you will need to update the modem firmware of the device. This can be done using the Programmer app. So go ahead and install the Programmer app in the nRF Connect for desktop. Then open it. Now, select your device. Once your device is connected, open your favorite web browser and then go to nordicsemi.com. From there, either navigate through software and tools and then development kits to the nRF 9160 DK, or type in nordicsemi.com/nRF 9160 DK. Then scroll down to the downloads field, and here you'll find either a precompiled package with the application and modem firmware to test different applications, or the modem firmware alone. For this part, I'll download the modem firmware alone. Now, do not extract that zip file, then go back to the Programmer app, click on Update Modem. Then you will get a browser which will allow you to select that zip file, select it, and click on Open. Once that is done, you'll get this message which states what file you are trying to update the modem firmware with and the status. With the development kit, you can update the modem firmware using the onboard J-Link device and click on Write. This will automatically handle everything for you. All right, you've updated the modem firmware. Go ahead and close the Programmer app, and we'll continue with the Toolchain Manager. Go ahead and install the Toolchain Manager. I've done this already, so I'll just open the Toolchain Manager. And then go ahead and install the desired release tag. Each tag that the Toolchain Manager installs a sandbox solution with the NCS repository and the required tools. So these tools are CMake, GNU ARM embedded tools, SES, Python, and so on. And then after you installed it, you can go to the drop-down menu where you can update the SDK and also update the toolchain. But you can also open bash or command prompt. And you can go directly to the SDK directory or the toolchain directory. There's also a small guide to show you how to build a sample project. But let's open the IDE. This opens Segger Embedded Studio for ARM, Nordic Edition. From here, let's go to File, nRF Connect SDK Project. And now we can open a NCS project. So we have the SDK release tag, and we have the toolchain version, which comes with this tag. Now we can choose the projects. So we're not going for the getting started or short range, we're going for cellular. Then the drop-down menu will show us what available applications and samples that we can use with the nRF 9160. So for this one, let's go with the AT client, and then we'll choose a board. We can choose the Thingy 91, or we can use the 9160 development kit. We'll choose the non-secure version for this one. And we see that the build folder is automatically added based on the board. Then click OK. Now that we're done opening the project, you can go to Build, Build and Run. When Segur is done programming the development kit, we'll go to the nRF Connect for desktop again. Then we'll open the LTE link monitor. Here, we'll select the device. We see that it doesn't output much, so let's reset the board by pressing reset on the development kit. Here we see the Secure Partition Manager printing out the available peripherals and then also showing what memory region is used, and then the application itself boots at the end. Then we have some pre-configured commands that we can issue to the modem itself down here. So we can just verify that the AT command is running. Yes, that is running. Then we can try asking it for what functionality it is currently in, what state the modem is in. It is currently offline or powered off. So let's issue the cfun equals to 1, which will put it in normal mode. It verifies OK. And then it runs. There you go. It's connected. We can see that it's connected to Telia Norway, and it's using the iBasis SIM. All right, so we've verified that this works. An alternative method of programming the device, if you don't like to use the IDE, is to go to the drop-down menu in Toolchain Manager, then open either bash or command prompt. Let's try with command prompt. So here's the command line, and from here let's go to the samples folders again. And then with the IAT client. And then here we can see that the build folder from the IDE is still here. Now we're going to use the meta tool of Zephyr West to build the project. So let's build for the board nRF 9160 DK. And then by doing this, it would automatically generate a build folder. Now we program the device using West Flash and then add the directory with -d, since there's 2 build directories now. And then we open LTE link monitor once again to look at the output. Here we can see that the latest output from the sample itself is the AT host sample started, same as we saw earlier. But as you can see, while we've been programming the AT host again using West, there has been output from the device. We can also see this in the log itself. Here we can see that it's been logging from the start as we started previously. It shows you all the way with timestamping when it did sent all the commands to the modem and received a lot of information. And then we can see the last one is reprogrammed the device, and then the AT host sample started again. All right, so here I've opened my NCS folder in my favorite editor, and we're going to copy the Hello World folder from the Zephyr samples. So the Zephyr samples are under Zephyr samples and then Hello World here. I'll just go ahead and copy, and then on this window I have a folder placed anywhere, my favorite little path, and then we'll just paste it in here. And then we have everything we need. We have the source with our application, our CMake lists, .text, and project configuration. And now we want to delete the README and sample YAML. We don't need those. Next, we're going to copy the board files from Zephyr, and then we'll navigate back to boards, ARM, and scroll down to nRF 9160, just past it. There we go. And we'll copy this. And now here we'll need to add a new folder, which is called boards. Oops, put it in my folder. Yes, move it in there. And then in that folder we need architecture folder, which is ARM, and in here we'll paste the board files. All right, so here we have all the files we need to start with a custom board. So it's recommended to copy these files because there's so many additional settings that you need in order for Zephyr to work correctly, that we recommend copying one of these and then figuring out what you need for your board specifically. I'll be going through the files just to show you kind of what we need and how they look inside of them. All right, so first we're just going to delete the documentation file or folder. The documentation is needed if you're contributing your board to the Zephyr folder or the Zephyr repository. But for now, let's just delete that one. The nRF 52840 reset is something we use for the development kit or our board controller, and that as well we can delete. All right, so now we have everything we need. Now the first thing I'm going to do is I'm going to rename the folder and every file below. So for my part, I'm going to call this the Hello Board. Just copy this, and then I'll rename every part of the files and everything inside the files that has anything to do with 91DK. I'll just rename that to Hello Board. Let me just go through and rename the files first. All right, so here we have all the files renamed. Now we need to edit anything inside of it. So just starting from the top. The board.cmake configures nRF JProg to the correct nRF family and configures JLink to the correct ARM device. This introduces the flash and debug functionality for the board. There's nothing we need to change in this one, so we'll just keep it as is. CMake lists.txt, as you can see, was for when we had the nRF 52840 reset file. And this one, we can see that if this was configured, it would include this file. And we'll get back to that later. So we'll just keep this as is. And there's nothing else in here that we need to change anyway. Then we have the Hello Board common, which is settings that are common for both secure and non-secure in the ARM MCU. So yeah, here I've already edited this one to Hello Board. We can also give this model name something else. Let's call it Hello Board. And the DTS file, or device tree source, is what configures the hardware on your board. So as we can see, we have different Zephyr console shell and UART configurations that are set to UART 0. Then we have LEDs that are configured to GPIOs. Here they're configured to GPIO 2 and then set to 0. We have different buttons, as same as the LEDs. This one configured to GPIO 8, and and so on. And further down we have the ADC and UART and so on. Here we have UART 0. Setting it to status OK will enable it. Then we see the current speed of that one is 115,200, and then we have the pin configurations. Similar to if you have I2C and PWM and so on. This is the initial configuration. I'll show you later how to configure, let's say, the I2C and how to change the pins if needed. Next, we have the def config for Hello Board. Oh, sorry. We'll see if was there anything else we needed to change in here. Yeah, we have the include file here. So as you can see, I changed that to Hello Board, so we need to change that as well and save that one. Then we go to Hello Board def config. These file types are used to set the initial configuration in a project. It is one of 3 sources that set the initial configuration of a project. If the same kconfig symbol, in this case, let's say config underscore GPIO, if it's set in both the def config and the application configuration, which is known as the prj.conf, the latter will take precedence. This kconfig symbol can be also, for example, the config AT host library, which enables the AT command interface of the modem. This means that when you build for the target Hello Board, in this case, the AT host will then be enabled. But we will get back to how we can configure that as well. Now we have the Hello Board partition configuration DTS. This is just flash planning. This allocates the memory for secure and non-secure image along with the BSD socket library, as we can see down here. It also sets the default flash location for the secure image and the non-secure image. Next is the Hello Board device tree source. This describes the hardware of the secure partition or secure domain of the board itself. As most of the hardware is configured with the common DTS file, this file configures the SRAM secure partition and non-secure partition. I recommend reading on the device tree source documentation, which is linked in the Zephyr library, to get a better overview on how this works. The board YAML files specifies the properties for your board, such as toolchain, supported features, RAM, and flash size, and is used for sanity testing. Now I see I've forgotten to rename several things here, so I'll just rename here. Sorry. And don't forget the hello board common DTS. Yeah, this one is okay. Then we have the hello board non-secured def config. So as mentioned, these are initial configurations set when building a project. Similar with the hello board non-secure. So here as well, rename and then rename it. Make sure to keep the NS. Yes, and of course, the defconfig file also needs to have hello board NS. And hello board defconfig. All right, then we have the kconfig file. These files describe build time configuration options, called symbols in kconfig speak, how they're grouped into menus and submenus when using menu config, and dependencies between them that determines what configurations are valid. So in order for these to be used, or let's say the other way, in order for this to be used here in the CMake lists, it needs to be defined in the kconfig. So for this part, we don't need to pay attention to this, as we do not have the C file here. We can remove it if as wanted. Then you have the kconfig board and the kconfig defconfig. Both these are software configuration in kconfig formats, which provide default settings for software features and peripheral drivers. So for the kconfig board, we can see that we have the hello board. We just need to give it a name. Hello board. And the same here. Hello board non-secure. Now here we have the kconfig defconfig, which here we set the name or target for the board. So this means that when we build for hello board, this is what's used. And then make sure to rename every part down here. All right. So just make sure to go over one more time to verify that you've added and renamed everything. And I didn't mention the SoC, so then we don't need to edit these because we're using the nRF 91 system on chip. So this we'll just leave as be. All right. Whoops. Here we go. Now we can try to build this project. However, because we have the trusted execution and the memory allocation defined via these settings, we need to add this here. I recommend finding the configurations from the nRF 9160 samples. This way you'll see the correct values and see how we have done it. So go ahead and go back to the nRF 91 NCS folder, then go into nRF, samples, 9160, and then you can just choose one. Let's go for the AT client and then go into the project configuration. And here we see that we need to add config main stack size and heap mem pool size. So we'll just copy that and go back into our code, paste it in. Next, we need to add a line to cmakelists.txt in order for Zephyr to see the board files. So we'll go back to cmakelists.txt, and then before the find package Zephyr required hints, we need to add this line. Now, according to the documentation from Zephyr, one needs to add the list append board root $CMake current source. So let me just add this to the file. Like so. And then add the last bracket after the curly bracket. Now we can go back to our toolchain manager and then open command prompt. Then navigate back to your project folder. Then west build hello board ns. Now we can flash the board. So we just go ahead and just west flash. Then open the LTE link monitor from the nRF Connect for desktop. Then select your device. So the LTE link monitor is targeted towards our cellular cellular products like the nRF 9160, so it will automatically, because of the automatic requests, it will print out 80 plus CFUN question mark. So just pay no attention to that one at the moment, but we'll try to reset the board. No. Okay, so we might need to just program the device one more time. Ah, there you go. As you saw, the AT command didn't work. So as I previously showed, you click on AT command, but this time it will fail. So let's add the AT commands to the board. Then go into your project configuration, then add config AT host library equal to Y. Also, we need to add the BSD library, so config BSD library equal to Y. Now let's see if this builds. So let's build board, hello board. Oops. Okay, so here we have an issue. Scrolling up, the first warning is BSD library. Was assigned value Y, but got the value N. Check these unsatisfied dependencies. Trusted execution non-secure. Okay. Here we see that there are some dependencies that we need to figure out. If we go to the hello board def config, first, did you notice that I built for the hello board and not for the hello board NS? So we built for hello board secure and uncertified dependencies, trusted execution non-secure equal to N. Okay, so let's go into the hello board def config first. We can see here that trusted execution is not set at all. Then board NS def config. Aha. This is set. Okay, so first indication we should try then is try to build for hello board NS. Excuse me. Here you go. So it should set, try to build West build for the target hello board NS. Okay, so that now removed the BSD library issue. Now we have netsocket POSIX name. Now that I know that we do not have at all, but I saw that from the AT client sample, those were set in the configuration. So let's go find those again. Let's just copy the whole configuration of the AT client and then go back to our project and then paste them in as well. Oh yes, and as well we will also add the config UART interrupt driven. All right, so then we'll try again to build our project. And then to do a clean build, we'll just add the P, pristine. All right. Then let's flash the device. Now let's open the AT command host or LTE link monitor, and let's try to issue the AT command. There we go. Okay. And that should see fun. Okay, so the modem is currently powered off, as you can see by hovering the mouse over the response. Let's put it into normal mode and then try to ask for the function again. All right. And it's connected using iBasis and with the IP address. Cool. So this is how one way to communicate with the modem. And from here you can do several other commands, but recommend looking at the AT command documentation to see all the different commands that you can send and receive with this AT command client. Okay, so let's try to add a sensor to the project. So what we need to do is I have a BME 280 sensor, and now I want to add that to our project. So we'll go back to the NCS folder. Now we need to find the sample, and it's under Zephyr samples, and then sensor, then BME 280. So similar to what we just did, I recommend just copying most of it. So copying the sensor data, I mean the configuration, and then the BME 280. So we copy these, and then we go into the source, and we just do it the easy way. We just copy everything and add that to our application. Just remove that part. All right, and then now is the part of editing your I2C. So let's go back into our build folder on from the project that we just built, under build, then Zephyr, and then Zephyr.dts. So here you'll see what our DTS files configured. Now we want to look at our I2C. So we can go down to I2C. Now we see that I2C 0, 1, and 3 are disabled, but 2 is okay, so enabled. And then pin 31 and 30 is set for the SDA and SAL pin. Now if you go back to the sensor example, and then under boards, it has this overlay file. So the nRF 52840DK underscore nRF 52840.overlay. Now this is configuring for I2C 0. But let's just copy this file. Then we go back to our folder and paste it in our source directory. Now when you add a overlay file, this file will overwrite the DTS file that we configured earlier. So adding a hello board ns.overlay will overwrite the hello board ns DTS. Or it won't overwrite it, but it will append whatever you add to the overlay file. So for us now, we will add to I2C 2, we'll add this child BME 280 at address 77, or for my part it's 76, as I know my device is. And we also need to add a kconfig file, because there are values in the main file that we need to add to our project. So sensor log level, log print k, and so on. So let's just copy the kconfig file as well, and then paste this as well to our project folder. Now let's try to build this again. As we added or edited the DTS file, we need to do a pristine build. So then we'll add -p on the end. Okay, and then we'll flash the board. There we go. Found the device, and then showing the temperature, pressure, and humidity. And as a last test, we can add the AT commands. Yep, it works. That's all we had time for today, I'm afraid. Please go to DevZone under tutorials to have a look at our Getting Started with nRF Connect SDK tutorial series. Also, have a look at our webinars.nordicsemi.com to look at our previous webinars, but also coming webinars. Now, it's time for our Q&A.